We're going to need to graph this logarithmic function. And we'll go through two ways of doing that, so see which one works easiest for you. And then we'll come back and forth. To do this, plot 2 points on the graph, and what we'll use is we'll use this tool here where we can actually enter the coordinates once we get those. And then also we're going to draw in the asymptotes. The asymptote, well, we're going to see when we look at this graph, is we'll get a vertical asymptote, not a horizontal. Let's put it that way. All right, so 2 points. I'm going to graph it here in a moment, and we'll just be able to pick the 2 points off of the graph, off of the table of values that we get. And I'll show you how to kind of think of it from there. Let's do this part first. So a lot of times when you know the answer, it's easier to find it, and it's easier to explain why that is. So I'm going to go to y equals. And again, notice Alex does not give you a calculator, a graphing calculator even, but you can bring your own and use it. That's why we want you using the graphing calculator. So we want minus log, so that's going to be this negative sign, not the subtraction sign. Log base 3. Now, with this calculator, if you have this feature, not everyone does, but hopefully you do. It's called log base. So it's been around for 10 years or so. So if not, you'll maybe need to update your operating system or something. But log base is very powerful because you get this. You just put in the base, and then we can put in our x, and we'll be able to actually graph this. Otherwise, you use the change of base rule, which I'm not sure it's even in here anymore because most of the TIs will have this as a feature. Okay. So we want to graph it. I'm going to go to zoom standard just to make sure everything is, and it comes down like this. Now what I got to think is it looks like it just comes out of this point. Where it's actually doing is there's this asymptote here at x equals 0. The y-axis itself is the asymptote, because the domain of a logarithm is x has to be greater than 0. It can't be equal to 0. If you put in 0, and one way you can check it, if you have any logarithm, and it doesn't matter if it's a base, but any logarithm, if you plug in 0, we're going to get an error that's undefined. It's a domain error. It's not in the domain. Also, if you put a negative inside any logarithm, any number, let's go with just -3, any negative, can't be 0, can't be negative. Okay, it's a non-real answer. But anyway, okay, so that's our domain. So we can kind of see by doing all of this, we see where hopefully if the asymptote is, this would keep going up towards positive infinity on the y side. But I'm going to show you how you can get these. You can see one point looks like it's going to be 0, 1. In most logarithms, that's going to be the case. We'll have that point. Then we need another one. And I'm going to show you that will correspond to this base. So regardless of the base, you're going to have 0, 1, because that's always there. And then the one that will match with this is if we plug in 3 for x, or powers of 3, 3 squared, 3 to the 4th, whatever. If we plug in 3, the answer is going to be 1, because the base is the same. Okay, actually it'll be -1, so we'll see how that works. But what I'm going to do now, let's see, what do we want to do first? Well, from this graph, hopefully you can see we have our domain, and our domain, again, from looking at the function itself, we know that x has to be greater than 0, not equal to 0. If you graph that out, here's 0, here's -infinity, here's positive infinity. 0 is not included, and we're going this way. Okay, so we get a parentheses here, a parentheses here. So that's going to be our domain. I guess that's all we have to do. And then we're going to have to graph it. So Let's go ahead and put in the vertical asymptote, and we have to put in any point. So since it's on the y-axis, actually it looks like it's already there. Let's see. Well, let me draw it. Put in 0 for x and anything you want for y. Let's just put 5, and it'll draw that asymptote. Okay, so we've got our asymptote. Now it'd be nice to have our 2 points. Again, I'm going to show you. You can go second table, and we can choose off 1, 0. You see all these arrows, error back here in the negatives, and even for 0. So 1, 0 is a good, nice, solid point. 1, 0. And the other one, I can see that's 3, negative 1. And I'm just going to go down here. You could choose any one of these that you want. 9, 3 squared is 9, negative 2. Okay, so, and I'll show you basically how you do with logarithms. But powers of 3 are going to be what we want. We got these nice solid points, 3, negative 1. Now you could use 4, but notice it's, if we come up here, show you, it's an approximate value. It goes on, there's decimal places all and on and on. So you can't get an exact value there. It's going to get marked wrong. So you want something like 3, negative 1, which is, that's an exact value. Okay. So those are the 2 points we can use. And what we're going to do here to graph it, we'll put in 1 and 0. We'll plot that point. And then we will put in 3 and negative 1 and plot that point. It's there. And we can kind of see it's matching our graphing calculator. We'll click on this. It's got the graph there, so we're good to go so far. We looked at our domain. We know our domain here is going from 0 to infinity, parentheses on both sides. And you'll see that with a logarithm, that's going to always be the case. The range, now it goes up to negative infinity, and actually this one's going to keep going down slowly, but it will go down to negative infinity. Something you're going to want to remember, the range for logarithms are always, unless you have some funky thing, but a general logarithm is going to have a range of negative infinity to infinity. And that's why I always do this number line. I didn't put any arrows on them, but as you do your number line, you'll see that, that what is all numbers, negative infinity to positive infinity. So we will do that. If you just kind of remember that, that's always going to be the case. Also, you can see from the graph. Now, if you didn't have a graphing calculator, which again you should, really highly recommend it, is the way to think of a logarithm. We've got negative log of 3. What we want to plug into x is anything with a 3. So log of 3 to the first power, the answer is the exponent. When your bases match, your answer is the exponent. And then there's this negative on the outside. So this part is 1, the negative goes on to it. Log base 3 of 3 squared is going to be 2 with the negative on the outside, right? 3 squared is 9. 3 to the third, we could have gone that route, but we're going to get very, this 3 to the third would be equal to, again with the negative out here, is equal to 3 with the negative on it. So the y value is only negative 3, but notice we would have to get out to 27. And our graph doesn't go out that far, so that's why we wouldn't use it. We could use the 9. You could put in 9, negative 2, and you see it there. But that's kind of how you want to think of logarithms, is use the base, and the exponent will give you your answer. So choose them wisely. Graph it, and you'll get the same connections between these two. And then it'll also help you understand the domain and the range. The range for logarithms is always going to be negative infinity to infinity. And the domain will always, if your standard just a log of x is going, it doesn't matter the base, it's always going to be 0 to infinity, not including 0. Okay. Now, if they've got something other than x in here, say x minus 1 or something, that can, again, do a transformation, shift the graph. So we'll probably be looking at some of those. All right, that's it.